algorithm? Yes. So I think you are new. I'm Ashish. Nice to meet you. Yeah. So we'll attempt to do tries today. That will be the beginning. Start guidance from scratch. And then there's two questions that he has been asking me for a long time. We'll do that. That is very easy. Like I don't know if that is easy or not, but like I don't have a solution. And then we'll do the graph. I don't know. Either we'll do stats and views, or we'll do the graph adjacency Dijkstra's algorithm. Solve. And I actually wrote the graph in C# in my office. Wow. C++. I just converted it from C# to C++ to C#.
चलो आज और एक ईमेल सेशन होगा.
So we will.
कि ना तो वो बैंक से आ गए.
बोला था ना उसके बाद पूछते ही क्या हो रहा है सबसे पहले मारते हैं मुझे आज इसमें दूसरा रास्ता इसके अलावा ऐसे भी समुद्र के किनारे कहीं पानी सुनामी उठ के आया तो
नहीं सुनामी इस पे नहीं आया
नहीं ऐसा नहीं है ना
ये लेक क्वेश्चन
नहीं क्या बात है हम रेस में ले जाते
तैरना नहीं आता.
वैसे तुम वो तो आ भी सकता है.
Okay, so we'll start with tries, and I have the C++ solution, and as usual, like you will, वो recording start हो गया.
हाँ कर दिया.
So as usual, we will get the you will do the C# conversion. Should be very easy. So tries is a structure like this. So this is my implementation. There can be other implementation too, and I have a very simple implementation so that like you guys, like I can understand that, and you guys, there's no optimization in this. You can optimize this as you can. So yeah, so tries is a structure like this in which you actually have a tree kind of a structure where something comes up, and let's say I added 2. So T will come, and then I will add another for TO, right? Let's say I added TEA, right? So I'll come over here, I'll check T is a child, so I'll not add anything, but this does not have E, so I'll add E, and E does not have anything, so I'll add TEA. Let's say I add Ted, so I'll come over here, TE, and this will be B.
But this is not a try, this is something else.
Suffix tree. Suffix tree is actually a different thing. Suffix tree and prefix tree. No. Suffix tree and prefix tree is different thing. I will try to do that. They are more difficult than this. Suffix tree and prefix tree is different. They're more different than that. I will do that in another class, not this one. Okay. So and then let's say we add A comes, so I'll just add A over here, and then let's say in comes IN, so I'll add IN. Let's say INN comes INN. You get an idea of where this is going, right?
What is the value of the root node?
The root node in my implementation it is empty. It is empty because that is where I start from. So okay. Now, if you look at it, what TE is actually not a word, right? TEA is a word. TEA. Okay. I'll get it. So, I'll see it there. So if you see, TE is actually not a word, but TEA is a word, TE is a word. So in my implementation, what I did is when you add a structure, so in that structure, this node will actually have a character value. So there will be a character, which is the value, C value. Were you there in the previous class?
No, I did it.
Oh.
I learned it by myself.
Oh, okay. And then I will actually add a Boolean value, which is
That indicates whether this is a termination of.
this is the terminal force. Yeah. And then what I did is each node, actually this can have multiple.
Right.
So what I did is I took a vector of all these things. So E has a vector which has A and B. E has a vector of similar nodes. Right? Vector means array list. So you take an array list of a node. So what I have is, I will now write the structure for this. I think like you understand what the structure is.
Right.
I'll start writing the class, and
So the root can have how many nodes it can?
as many
Only
26 characters
So
and
every node will hold 26, right?
can have every
They
node can have
little different
maximum
than
26. Yes.
No, that is what we learned.
Yeah, every node can have maximum 26.
I have the Karamachi book in
Okay.
my car.
Okay.
So we have learned in a different way.
Okay. Yeah. So as I said, I actually
What is different way? It should be the same.
it should be almost the
So
same.
every node for a trias should have 26 nodes which will point to a null, and there will be an extra element which will be
two values.
which will be, and one more field is called data, which will tell us what the data
Sure.
of that element is.
Sure. But in my implementation, there is no error checking because they can be 26 plus 26.
No.
No, in my implementation.
In our implementation,
In my
26
implementation,
plus
A is there and then A is there. These two are different words.
Okay. Yeah. So.
Yeah. So, but anyways, this is a very simple implementation. So I will start writing the class. Okay. Class A tries, which has a public. Public will have a constructor and a destructor. We will not have a destructor. Do we have destructor in C#?
No. But yeah. We can implement. but
We
not
can
required.
implement. Because I was actually, when I was writing the graph, I tried writing till the graph and it actually compiled. So I was
Yeah,
like, okay, yes, you can actually do that. So add string and std : string. This is C++ string sg value. Okay, and Boolean search word, which has sc search. These are two functions. I will implement these two functions. There can be other functions also. I'm not going in there. Private will have a structure, a tries node, and that structure will have a character C value, and Boolean is end character, and then vector, a vector of a tries node, children. So each node has an vector or array list of children. So each node can have a list of nodes. That is how we define the thing. And then we need a root. So we will make a tries node star root. Okay. And then there is void delete node, a tries node. My handwriting is becoming horrible. So we have the destructor will call this to delete the entire thing, and then a tries node star find node. So find node, what it will do is it will find a node in your children. I think that's what it does. I don't know. We'll see. A tries node star child comma character. I don't know what this function does. We'll look. Okay, so this is pretty self-explanatory, like the structure. I don't know if you guys have any questions, just ask me. Yes, no? Anybody need coffee? Wake up.
What is the difference between trees and tries?
Trees has, it is almost the same thing. It is basically almost the same thing. Yeah, don't lock it.
Then what is the advantage of tries?
The difference would be like trees can have any number of nodes. Tries will have only fixed 26 or maybe 26.
Between trees and tries, I think it's almost the same thing.
Yeah, tree is just a different word.
It's just a different version of it. Tries is just a different version.
It has a specific purpose. It has been implemented for
Yeah.
dictionary kind of uses, right? So tree is a normal structure, a generalized structure, and you can define your own structure based on that structure, right? So you can say that the tree is a subset. The
Subset.
trie is a subset of tree.
Right. Yes.
It can have many children. Like many nodes can be
Yeah.
attached to one.
No, but a tree can also have many nodes.
No, but the tries node will only be specific to
Right.
these element whatever we specify, not
Yeah,
more
maximum
than that.
to 50. 52 plus something node we can.
So for example, a good example comes to my mind is DNA.
Yeah.
That's what it's used for try, because suppose at the root level you start at a D,
Yeah.
or your DNA starts with C. So now there are all possible combinations. So you have to go through that branch. So you start with something like
We don't know DNA.
No,
First explain.
DNA is double helical structure, which is like A, B, C. So there's a sequence to it. So like it's A, B, B, C, C, A, B, B, or something like that. So if there's two different DNA, then you start actually comparing, can we go actually in this path or not? So something like that. We have too many things to
I was
finish today.
thinking medical DNA.
No.
that is
It is a medical DNA, right?
Okay.
वही वाली बात।
There is only one DNA.
Okay.
I thought that is your
Add
DNA.
string method will add.
Alright, do not
And add string will add to that tree,
Node.
to that, yeah, entire tree.
Like we're doing T's, S
Yes.
is your right S.
Yes. Okay, so I will,
मुझे नहीं पता था. I'm not a medical student.
okay, so I'll write the constructor, A tries, colon, A tries. And what we will do is we'll instantiate the root.
Right.
So root is equal to new A tries node. So we'll just create a new node, and value we'll just add root
We can leave.
arrow C value is equal to, yeah, we can leave it null. I'm just adding a null value, and then what I do is root arrow is end character is equal to false. Just a simple, like you can add false or true or whatever. The destructor, what it will do is for integer I is equal to 0, I is less than root arrow children dot size I plus plus to call delete node of root arrow children dot add I. So what will happen is if there is a root which has A, B, C, D, I'll start with the root and I'll call the first one and say, go ahead, delete all your children. This will call that, and so the delete node function will be called for every child, and every child will in turn call delete node for its children recursively, so everything will get deleted. So that is how the destructor will work. I will write the, if you don't understand my handwriting or if you are not understanding it, I can explain it again. Okay?
Then who will delete A, B, C, D?
So this root will call delete A. A, let's say, has three different things. A will call delete all my children. This will call delete all my children. So it will start from here, it will delete all these elements. Then it will come up here, it will delete itself, and then A will delete its children. So it will call recursively, and that is how you delete.
So it is similar to
Pretty,
NRA.
pretty similar to NRA, actually. Yes. So different names. Just somebody wants to add their name on Wikipedia, they came up with a different structure, and it starts getting used.
But it is same like that. Right?
Huh?
It is same like NRA.
It is. Yeah. So A tries delete node. Let's see. A tries